Hi, good afternoon, everybody. Welcome to another episode of Math with the Thinker's Cap. Okay, my name is Mr. Tam. Okay, in today's lesson, we're going to talk about a topic that is usually taught in Sec 4 E-Math. Okay, probably the last few chapters, right, after we have learned similar triangles, and that is the topic on vectors. And in this question, we're going to see how a question in vector can be combined together with the concept of similar triangles, okay, and to find out the ratio of the sides and an expression of a vector in terms of the two other vectors. Okay, let's take a look at this example here, right? Okay, in this case we have a rectangle ABCD, all right, and we can actually indicate the parallel sides, all right, and I have AE equals to EF equals to FB, right? So I'm going to indicate it here as three equal parts. Okay, DF and CE intersect at G, right? So this is the point of intersection, and I've got DC represented by vector U and DG represented by vector V, right? So in this case, we are going to express EF and CG in terms of U and V. Okay, so identify where is our EF first. Okay, EF is in fact one third, okay, of DC. Okay, since we know that EF is one third of AB, and therefore AB is the same as DC, because in this case it is a rectangle, and therefore we can conclude that EF is one third of DC, and we can write our vectors one third U, right? So that's the first part, okay, for EF. And for CG, right, CG is the vector in this direction, CG. So if we were to look at this triangle here, all right, so using the addition of vectors, we can say that CG is the same as CD plus DG, all right, and CD would be the opposite of DG. So I've got minus U plus V, and that would give me my CG. Okay, part B, we are asked to show that EFG, triangle EFG is similar to CDG. Right, so these two triangles, okay, let's mark it out and see how do we find the rules of similarity. All right, so in this case, since we are given angles, the sides are not known, so most likely we're going to use our AA similarity rule to prove that these two triangles are similar. All right, so the first angle we're going to prove that they're same is my angle EGF is the same as angle CGD. All right, and the reason for them being the same is because they are vertically opposite angles. All right, these two are straight lines, right? EC and DF are straight lines. Okay, the next angle they're going to show would be my alternate angles, right? Okay, in this case, I have a rectangle here, therefore DC is the same as is parallel to EF. All right, so we can say that angle FEG is the same as angle DCG, right? And the reason is because they are alternate angles. All right, therefore, since I have got two angles that are the same, I can conclude that triangle EFG is similar to triangle CDG. Okay, and the reason is AA similarity rule. Okay, the next part, okay, C. Okay, we're going to express the ratio of CG to CE. I'm going to find a numerical ratio for that, right? So in this case, okay, let's assume that the ratio is, we're going to put it as a fraction, okay, CG over CE, okay, as K. All right. Therefore, my CG is K, and since CE is actually 1 unit, okay, divided by 1, I can say that EG would be 1 minus K. All right. So using the similar triangles that we have found in B, okay, I can say that using similar triangles in B, right, I can say that EF over CD is the same as EG over CG, right, by reason of similar triangle properties. Okay, let's plug in this value, EF over CD. We know that this is 1/3. All right, and CG, EG, right, we have already identified this as 1 minus K over CG would be K. So EG over CG would be 1 minus K over K. So now we can proceed to solve for K, right? And in this case, you'll get K equals to 3 minus 3K. 4K equals to 3, which implies that K is 3/4. All right. Therefore, my ratio of CG is to CE is 3:4. We're going to express this in terms of ratio because that's what the question requires. All right, so there we found our part C. Okay, in part D, okay, we are asked to express DE in terms of U and V. Okay, let's take a look at where is our DE, right? DE is located here. All right, so in terms of the addition of vectors, you can express DE as an addition of DC plus CE. All right. Okay, in the first instance, okay, my DC is already known. My DC is in fact U. How about CE? CE from the previous example in part C, okay, I can say that CE is actually 4/3 of CG. Okay, from the previous part where we found the ratio of the size. Okay, so therefore I can express CE as 4/3 of CG, and CG we have already found from part A is equals to minus U plus V, right? And therefore in this case we can open up the brackets and simplify this vector 4/3 U, and we will have 4/3 times vector V minus 1/3 vector U. And there you have it, part D, where I've expressed DE in terms of U and V. Right, so in this case, this question actually combines the concept of vectors and the concept of similar triangles. And this is a rather common question, right, that students are expected to know how to solve, right, in Sec 4 E-Math. Right, so if you like this lesson and like to find out more about our classes, right, click on our link below and check out our classes, and I'd like to see you on the other side. Okay, thank you.